All right, so in assignment number 9, we are still talking about rational expressions, but really, more specifically today, rational equations. And we're going to solve these equations today, and we're even going to get to applications of some rational equations where you might see them. So let's go ahead and get started. First one, instead of just having where we're multiplying or dividing or adding two rational expressions, they're equal to each other. This is a proportion. You've done questions like this before, but maybe not like this. We could go ahead and cross multiply here, but before we cross multiply here, I think what I'm going to do is I'm going to factor the denominator here. This could be factored as x plus 3 times x minus 3. And so if I were to multiply both sides by x minus 3, if I multiply this side here by x minus 3, these cancel. If I multiply this side by x minus 3, then these cancel. And so really this is the same thing as having it be 1 over 6x over x plus 3, because the x minus 3's will both cancel each other out. Well, then I can multiply both sides by x plus 3, and if I multiply the x here, or the left-hand side by x plus 3, I'll just have x plus 3 equals, here the x plus 3's will cancel, so it'll be equal to 6x. Then I can subtract an x from both sides, so that 3 equals 5x. And if I divide by 5, x is 3/5. And so we can actually plug that back in to make sure that it works. If I did cross multiply ahead of time, I would get a quadratic equation. I would actually end up with two solutions. One of them would be x equals 3/5. The other one would be x equals 3. But then you'd have to look back at your equation, because this one can't work because it makes the denominator equal to 0. And so that's a real quick look at our first example. Let's take a look at our second example. And what I'm going to try to do here is I either have to subtract these two fractions together first so I can cross multiply, or what I can do is get a common denominator here. And so here I have a 5x, here I have a 3x, and here I have a 3. I believe my common denominator, if I made a common denominator for all three fractions, is going to be 15x. And so what I'm going to do is make all of these 15x. Here I'd have to multiply this denominator by 3, so I'd have to multiply the numerator by 3, and that's going to give me 9. Here I'd need to multiply the denominator by 5, so I'd multiply the numerator by 5, and that's going to give me 20. Here I'd have to multiply both by 5 and x, so I'm going to multiply the numerator by 5 and x, and that's going to give me 5x. So now the denominators are all the same. If I multiplied by everything by 15x, they would all just cancel each other out. So if they cancel each other out, I would have 9 minus 20 is negative 11. That equals 5x, and if I divide by 5, then x is going to equal negative 11/5, which is the same thing as negative 2.2. Oops, that equals x. Or we could write it this way. And again, we could plug that back in to make sure that it works. Let's do another example here. This is before we get to the application still. And again, what I would want to do is get the denominators to be the same. So this denominator, if I factor an x out, is just going to be x times x minus 5. Here I have an x, and here I have a 2 times x minus 5. So if I put all those together, my common denominator is going to be 2x times x minus 5. And so I want every denominator here to be 2x times x minus 5. And so, boy, that's messy there, but we get the idea. So in order for the first fraction here to have this as my denominator, I need to multiply it by 2, which means I'm going to multiply the 7 by 2, and that's going to give me 14. And so, but then I need to multiply this denominator here by a 2 and an x minus 5. So I'm going to multiply this 2 by 2, which is going to be 4, and an x minus 5. And so that's going to be, if I distribute it, 4x minus 20. then this denominator here, I need to multiply it by an x to get this x here. And so if I multiply the denominator by x, I'm going to multiply the numerator by x, which is going to give me 3x. So my denominators are all the same, 2x times x minus 5. So if I multiplied everything by 2x times x minus 5, those would just simply go away. So what I would have then is 14 plus 4x minus 20. Well, if that simplifies, or if I simplify that, that's going to be 4x minus 6. And that equals 3x. And so what I'm going to do is subtract 4x from both sides. So negative 6 equals negative x, which means that x is equal to 6. And again, I could plug that in to make sure that that is accurate. But that's what I would have for number 3. Let's move on to number 4. Now, 4, 5, 6, and 7 are all applications. And so part of the struggle is going to be to set these up. And so you might need to watch this several times just to get an idea of what's going on. Let's go ahead and read this. The aerodynamic covering on a bicycle increases a cyclist's average speed by 10 miles per hour. The time for a 75-mile trip is reduced by 2 hours. So with the covering, you can reduce the 75-mile trip by 2 hours. What is the average speed for the trip using the aerodynamic covering? So to do this problem, I'm going to start with this. Remember this formula, distance equals rate times time. Well, if I get the rate by itself, that means I'm going to divide both sides by time. And what I'm going to have is that the rate is a distance divided by time. And what they've told us here is we have two rates going on. We have the rate with the covering, and we have the rate, I'm going to say, without the covering. And we know that the rate with the covering is 10 miles per hour faster. So if I subtract 10 from that, I would get the rate without the covering. So this might be 30 miles per hour with the covering, 20 miles per hour without the covering. You can go 40 miles per hour with the covering, you can go 30 miles per hour without the covering. And so we're just going to subtract 10 so that they are equal to each other. And then I'm going to replace each of the rates with a distance. If I go 75 miles with the covering, and let's say I do that in x hours, minus 10, I can go 75 miles without the covering, but it's not going to be in x hours. It's going to be in x plus 2 hours because it's going to take 2 hours longer. And so I want to then solve this equation. And just like I have done before, I want to get a common denominator. And so my denominator is going to be x times x plus 2. So I want every single one of these fractions to have a denominator of x times x plus 2. So I have this one minus the 10, 1 equals the 75 over, but I want to change it to x times x plus 2. And so what do I need to do to change this one to make it look like that denominator? I need to multiply it times x plus 2. So it's going to be 75. If I multiply the denominator by x plus 2, I'm going to multiply 75 times x plus 2. Now this denominator is 1. So that means I'm going to subtract the 10, but I'm going to multiply it times x and x minus, or x plus 2. And that's what this fraction is going to look like, 10 times x plus 2 over x times x plus 2. And then over here, I already have the x plus 2. I just need to multiply it by x. This is plus 2 here. So I'm going to multiply this by x. So that is 75x. So now that my denominators are all the same, I really don't need them anymore. I'm going to simplify this. I'm going to take 75x plus 150. I'll write it up here. 75x plus 150. And then I'm going to subtract. It's like a negative 10x times x, so that's minus 10x squared, minus 10x squared, and then I'm going to take negative 10x times positive 2, which is going to be negative 20x, and that equals 75x. So then I want to put all of this together. And so I'm going to move everything to the right side of the equation. And the reason for that is because I want my x squared to be positive. So if I move this negative 10x squared to the right hand side, it's going to be 10x squared. Then I have 75x and 75x. If I subtract 75x from both sides, those both disappear. But then I'm going to have the negative 20x. I'm going to add that to the other side, which is positive 20x. And I'm going to subtract the 150, so it's minus 150 equals 0. Now, to make my factoring a little bit easier, I'm going to divide everything by 10. I'm just going to have x squared plus 2x minus 15 equals 0. Then if I factor this, I'll have x times x gives me x squared, a positive 5 and a negative 3. Multiply together to give me negative 15, but add to 2x in the middle. So if I set both of these equal to 0, x is either going to be negative 5 or x is going to be positive 3. Well, x, remember, represented that I would go 75 miles in so many hours. And so I can't go negative hours, and so it has to be 3. And so this is going to be my answer here, or my value for x. But the answer to the question, remember, it says what is the average speed for the trip using the aerodynamic covering? Well, using the aerodynamic covering, it's 75 divided by 3, which is 25 miles per hour. If they had asked what is the average speed for the trip without using the aerodynamic covering, then it would be 75 over x plus 2. Well, that's 75 over 3 plus 2. 75 divided by 5 would be 15 miles per hour. So you want to make sure that you're answering the question that is asked in the question. So let's go ahead and do another example here. Example number 5. Joe is rowing at a rate downstream that is 4 miles per hour faster than his rate going upstream. Again, we're going to use this relationship. The rate is equal to the distance divided by the time. And we have his rate going upstream, and we have his rate going downstream. And how are they related to each other? Well, his rate going downstream is 4 miles per hour faster. So I'm going to subtract 4 from that so that they're equal to each other. Well, now I'm going to substitute things that I know. His rate going upstream, it says that he can go 3 miles upstream in the same time it takes him to go 5 miles downstream. So his rate going upstream, his distance is 3 miles in a certain amount of time. His rate going downstream would be 5 miles in the same amount of time, minus the 4. And that's how I would set this one up. This one's a little easier to solve because I need a common denominator, which is going to be x. If I put an x down here, I'd need to put an x in the numerator. And so then I can get rid of the x's in the denominator, and it would just be 3 equals 5 minus 4x. If I subtract 5 from both sides, I'll have negative 2 equals negative 4x, which means x is equal to a half. Now that's my value for x, but I want to answer the question. How fast is his rate going upstream? Well, his rate going upstream is 3 divided by x. So that would be 3 divided by a half, which is 6 miles per hour. And so going upstream, he would be able to go 6 miles per hour. I'm going to go ahead and stop here, and I have 2 more examples in another video. And so this will be part 1, and then there will be another video on this lesson that will be part 2. And so not very long, but just 2 more examples.